Hello Aganitha. I'm Arghadeep Dey, and I want to discuss about the first question from the quiz. That is, what will be the equilibrium distance between two vectors if the cosine distance between them is zero? So, before diving deep, let's first understand what is meant by cosine distance and equilibrium distance. So, suppose we have two vectors, v1 and v2, and angle between them is theta. So, cos theta is equal to the dot product between the two vectors v1 and v2 divided by the magnitude of v1 multiplied by magnitude of v2. So, cosine distance is given by 1 minus cos of theta. On the other hand, if we have two vectors x1 y1 and x2 y2, the equilibrium distance is given by root over of x2 minus x1 square plus y2 minus y1 square. So let's understand this question from two scenarios. In one scenario, we have a vector x2 y2 and x1 y1, and both of them are perpendicular to each other. So the angle between them is 90 degrees. So in this case, cos theta is equal to 0, and hence the cosine distance is equal to 1 minus 0 equal to 1. But the equilibrium distance is given by root over of x2 minus x1 square plus y2 minus y1 square. In the second scenario, we have two vectors 2 comma 2 and 1 comma 1 in the xy plane, and since both of them are pointing towards the same direction, so the angle between them is 0 degrees, and in this case cos theta is equal to 1. Hence the cosine distance is equal to 0, but the equilibrium distance is equal to root over of 2 minus 1 square plus 2 minus 1 square equal to root 2. So in this case we can see that while the cosine distance is 0, we have the equilibrium distance as root 2, and we can have a general approach that if that while the cosine distance depends on the angle between the two vectors, the equilibrium distance depends on the magnitude of the two vectors, and it's not limited to any range. So thank you.